The traditional power grid provides reliable power most of the time. However, when natural disasters or technical problems threaten the grid, the ensuing blackouts can be catastrophic and costly. Companies and utilities are working together to build resilient, flexible power systems called microgrids. Microgrids are smaller, local power grids that can be coupled to a centralized national grid, but also as self-standing systems. Microgrids are implemented in hospitals, rescue services, industries, and wherever the power supply cannot be interrupted. Microgrids are reliable, adaptable, and resilient. They are designed to provide uninterruptible power to the loads, even despite natural disasters and technical problems. Microgrids are the future of energy infrastructure. They can easily incorporate green energies, making the supply of loads through renewable energy sources more efficient. Lucas-Nuelle's microgrid training system includes up to 4 synchronous generators to emulate a microgrid and can be expanded with renewable energy sources. One single generator can form a small microgrid, but it can also assume the role of the primary system that determines the frequency and the voltage of the microgrid when further generators are connected operating in island parallel generation. The secondary systems are less complex and they need to be synchronized to the primary system. Every workstation requires a controlling computer where the SCADA interface is running. Lucas-Nuelle's equipment can be set up easily. The wiring instructions for all the experiments can be found in the respective LabSoft courses. For the wiring, safety measurement cables and connection plugs are used. Next, we'll show you how to configure some of the devices in order to establish communication with the SCADA software. To control and supervise the microgrid, communication between the intelligent devices and the SCADA software must be configured. As an example, we show here how to configure the IP address of the human-machine interface of the generator. Navigate to the settings menu and enter the communication option. Set the IP address using the arrow and the plus button. Make sure that all the other devices and the PC are on the same network and have a unique IP address. Once we have prepared the hardware, we should configure the communication with the devices using the SCADA for Power Lab program. Open the proper interface and go to the device manager. Adjust one by one the addresses of the devices or select the proper COM ports. Eventually, the SCADA remote control server or client should be also adjusted. By pressing the start button, the communication with the devices can be established and the experimentation can start. This was our first video in our microgrid series showing the primary and secondary systems, wiring, communication settings of the hardware, and the SCADA for Power Lab. Check out the next videos to learn about the possibility of automatic synchronization and the different operating modes of the microgrid.